Hello everyone, so in this video, let us talk about an easy problem from LeetCode. The problem name is binary tree tilt. Okay, so let us go with the problem statement first. The problem statement goes like this, that you're given a root of a binary tree and you have to return the sum of every tree node's tilt value. Now what is that tilt? So tilt of a tree node is actually the absolute difference between the sum of all the left tree node values and all the right tree node values. Okay, you just have to find out the difference between the left half like node values sum as well as the right half node values sum, and just do an absolute difference between them, and you just have to add it for all the nodes, and that is the solution you have to return, the overall solution you have to return. Now how can you approach such type problem? So it is a very, you can say, a standard type problem, modification of a standard problem, in which you have to find out, let's say, a binary sum tree. Okay, and what is a binary sum tree? In which every node actually contains the sum of the left half and the right half of a particular tree. Okay, and if you just get the sum, then instead of finding out the sum, you just get a difference, and you just have to add all the differences, and that's the whole thing. Okay, and I think so that is much. Let's take one small example so that you can understand it more clearly. And let's take one tree. Let's say the tree is like this. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. This is the whole tree. Now what you will do is that I just have to find out the sum of the left half and the right half. Okay, so what I'll try to do is that if I want to find out the sum of the whole tree, I'll actually make a sum by like a binary sum tree. We'll go through that, but let's say I have to actually find out the tilt. So what we'll do is that I will make a global variable, let's say tilt equal to 0, and whatever I'll find out the tilt for every node, I'll just store that. Okay, or else you can also make a variable and pass it through every function call, but it's just your call. Now what I'll try to do is that I'll make a function that will just give me the sum of all the left node, like all the nodes value in the left subtree, and similarly call this function for the right subtree. Now to get the sum of all the node value on the left subtree, I have to again go on this node, and then for this node I'll again call to get the sum of all the left subtree value and on the right subtree value. Now because there is no subtree on the left hand side for this node, it will return 0, and this will return 4. Okay, so I'm actually building a sum tree only. Okay, but so what I have to transfer above, because this call is actually asking me to get all the sum values. Okay, so if I want to send the sum value, I'm actually building a sum tree only. Okay, but instead of building a sum tree, at every point I will also find out a difference. So the difference between this call is sending out 4, this is sending out 0, so 4 minus 0 is 4, so tilt is increased by 4. Okay, for this particular node is 4. Okay, and the sum of these nodes is 6, so this is transferred 6. So what I will be transferred above is, in the return call, is whatever is the left subtree value and the right subtree total node values will be returned from this function, but there's a global variable that is storing out the difference between them. Got it? So I'm actually building a sum tree, but I'm actually also storing out the trees. Now similarly, when I go to the right half, I'll have to find out the sum of all the nodes in the right half. I'll again call this function on the left hand side and right hand side. So when I call the left hand side, it will again check that there is no left hand side more on this, on right hand side more. So this will return the sum of this. It will return 5. This will return 6. So I'll get the difference between them, that is equal to 1. So 5 minus 6 equal to an absolute difference equal to 1. So this is actually, and this is 5 and 6. And when I get 5 and 6, I will transfer 5 and 6 on the top of this calling function. So it will transfer the left half value, right half value, and the current node value. So this is transferring 6, and this is transferring, let's say this is 8 plus 6, I think so 14. This is transfer 14, and 14 minus 6 is again absolute difference. So you see that what you can say, so 4 minus 2, 8. 8 is again, so 8 is again as an absolute difference. So you will get an absolute difference of, let's say, 9, 30 for this particular. And that's all the logic for this problem. Let us move on to the code part now, so that will become more clear to you. So what we have done is that we have called this solve function with this particular node on which you have to find out, and because you are actually finding out the sum tree, we are sending it as 0. Now this is the total, that is the tilt. So as you can see that it is made as a global variable. Okay, now once the solve function is called, it is just a recursive function iterating over the whole tree, that is O of n function. But what we're trying to do is that first the base condition, if the root is null, there is no more subtree, I'll return 0. Then I'll go and find out the sum, and I'll again call this function to find out the sum for the left half and the right half. So left half it is called, right half it is called. Now I have the left half and right half value. I'm assuming that this solve function will return the sum of all the nodes on the left hand half and the right hand half. That is what we got. So the total, that is the tilt, will be actually the absolute difference between both of these values and increment it. Okay, you can also send this tilt along this function call, but it's better to just make it a global variable. And we have added that. And now the actual function call, because this function will actually return the sum of all the left half subtree and the right half subtree. So when we have got that, what is this function will actually return to its parent is actually again the left half, the right half it got, and the sum of the root node. Okay, because that is also contributing in the left or right half, whatever it is. And then so left half, right half, and the root value is again transferring back to its parent so that it can again like calculate out the left half and the right half subtree value. So this is actually just building out the sum tree. Okay, and then in the same manner, I'm just finding out the tilt for every node by just finding out the differences and just printing out the total answer. That's the whole thing. So I'm just doing an O of n approach to just iterate over the whole tree, and that's nothing much complicated here. So an O of n stack is also used, but if you're using that, then you're also taking as the space complexity as O of n. If you're not considering that, there is no extra variables or like extra spaces used, so it is constant, whatever you can think of that. Total time complexity is O of n. And that's it. That is the overall code part and the solution and all the time complexity and space complexity for this problem. If you still have any doubts, you can mention down in the comment box of this problem.